Welcome to our channel. Today, we're diving into some mind-blowing science facts that will change the way you see the world around you. We're talking about the kind of stuff that makes you realize just how much we don't know, the kind of stuff that keeps you up at night staring at the ceiling and pondering the vastness of the universe. Get ready to have your mind blown wide open because we're about to explore the strange, the counterintuitive, and the downright unbelievable. From the depths of our own planet to the farthest reaches of space, we're about to embark on a journey of discovery that will leave you questioning everything you thought you knew. So buckle up, get ready to expand your horizons, and let's get started. You probably learned in school that water has three states: solid, ice, liquid, water, and gas, steam. Seems pretty straightforward, right? Well, the universe loves to throw curveballs, and this is one of its most fascinating. Let me introduce you to the triple point, a very specific temperature and pressure where water throws a cosmic party and exists in all three states simultaneously. We're talking 0.01 degrees Celsius, barely above freezing, and a pressure about 600 times lower than what we experience here on Earth. Imagine a glass container with ice at the bottom, liquid water in the middle, and water vapor swirling above it, all at the same time. It's like the universe can't make up its mind. Now you might be thinking, Neil, that's cool and all, but what's the big deal? Well, the triple point isn't just some scientific curiosity, it's actually a fundamental point of reference in physics and chemistry. Scientists use the triple point of water to calibrate thermometers and define the Kelvin temperature scale, which is based on absolute zero, the lowest possible temperature. So, this bizarre state of water actually helps us understand the universe in a much deeper way. But here's the thing about the triple point. It's incredibly difficult to achieve. You need incredibly precise control over temperature and pressure, which is why you won't find water pulling this trick in your kitchen. The triple point is a delicate dance of physics, a reminder that the universe is full of surprises, and that even something as seemingly simple as water can still hold mysteries that make us scratch our heads in wonder. But let's dive a bit deeper. The triple point of water is not just a quirky fact, it has practical applications that impact our daily lives. For instance, the precise calibration of thermometers ensures that medical equipment gives accurate readings, which is crucial for diagnosing illnesses and administering treatments. Imagine the chaos if our thermometers were off by even a few degrees. The triple point also plays a role in the food industry, where temperature control is vital for food safety and quality. And let's not forget the role it plays in scientific research. Laboratories around the world rely on the triple point to conduct experiments that require precise temperature conditions. This helps in the development of new materials, medicines, and technologies. The triple point is like a backstage pass to the inner workings of the universe, giving scientists the tools they need to push the boundaries of what we know. So the next time you pour yourself a glass of water, take a moment to appreciate the incredible complexity hidden within that simple liquid. Water is not just a life-sustaining substance, it's a gateway to understanding the fundamental principles of our universe. From the triple point to the vast oceans, water continues to be a source of wonder and discovery. It's a reminder that even the most ordinary things can hold extraordinary secrets waiting to be uncovered by curious minds. Let's take a trip to our planetary neighbor, Venus, a world shrouded in thick clouds and shrouded in mystery. Venus is a planet of extremes, scorching temperatures, crushing pressure, and a day that lasts longer than its year. The surface of Venus is hot enough to melt lead, with temperatures reaching up to 900 degrees Fahrenheit. The atmospheric pressure is about 92 times that of Earth's, equivalent to being 3,000 feet underwater. You heard that right. On Venus, a single rotation on its axis, what we call a day, takes a mind-boggling 243 Earth days. This slow rotation means that if you were standing on the surface of Venus, you would experience a day that lasts nearly 8 months. That's right, you could watch an entire season of your favorite show on Venus before the sun even sets. Imagine the patience you'd need to wait for the next sunrise. But here's where it gets even weirder. Venus takes only 225 Earth days to complete an orbit around the sun, its year. This means that while a day on Venus drags on for what feels like an eternity, its year is actually shorter than its day. So on Venus, a year is actually shorter than a day. Talk about a long work week. Imagine having to wait for months just to celebrate your next birthday. And if that wasn't strange enough, Venus rotates in the opposite direction to most planets in our solar system. This retrograde rotation means that if you were on Venus, you would see the sun rise in the west and set in the east, a complete reversal of what we experience on Earth. That means that on Venus the sun rises in the west and sets in the east. This unusual rotation pattern adds to the planet's mystique and makes it one of the most fascinating objects in our solar system. Imagine waking up to a sunset. That's life on Venus. The sky would be painted in hues of orange and red, creating a surreal and otherworldly landscape. Scientists believe that this backward rotation might be the result of a massive collision billions of years ago, which knocked Venus off its axis. This cataclysmic event could have drastically altered the planet's rotation and contributed to its extreme conditions. Whatever the reason, Venus stands as a testament to the incredible diversity and strangeness of our cosmic neighborhood. Its unique characteristics continue to intrigue scientists and inspire our quest to understand the mysteries of the universe. Chapter 3. The Sound of Temperature. Hot or cold, your ears know. We experience the world through our senses, and sound is one of the most powerful. But did you know that you can actually hear the difference between hot and cold water? It's true. It all comes down to a property called viscosity, which is a measure of a fluid's resistance to flow. Think about honey. It's very viscous, meaning it flows slowly. Water, on the other hand, has lower viscosity. Now here's where temperature comes in. When you heat water, its molecules move faster and spread out, making it less viscous, thinner, and allowing it to flow more easily. Cold water, with its slower moving molecules, is denser and more viscous. So, when you pour hot water, it creates a higher pitched sound because it's thinner and vibrates more rapidly. Cold water, being denser, creates a lower pitched sound. It's a subtle difference, but if you listen closely, you can definitely hear it. The next time you're waiting for your morning coffee or tea to cool down, try it out. You'll be amazed at what your ears can tell you about the world around you. Chapter 4. The Weight of Wonder Clouds and Their Million-Pound Secret. Look up at the sky on a partly cloudy day, and you'll see fluffy white masterpieces drifting effortlessly across the blue canvas. These clouds, often resembling cotton balls or tufts of cotton candy, seem to float without a care in the world. They seem so light, so ethereal, almost weightless. It's easy to imagine that they are just puffs of air, barely there at all. But here's the mind-blowing truth. A single cloud can weigh over 1,000,000 pounds. Yes, you heard that right. Despite their delicate appearance, these clouds are heavyweights in disguise. We're not talking about storm clouds here, but your average, everyday cumulus cloud, the kind that look like cotton candy castles. These are the clouds that dot the sky on a sunny afternoon, bringing a sense of calm and wonder. These fluffy giants can hold millions of tiny water droplets, and all that water adds up. Each droplet is minuscule, but together, they create a massive weight. In fact, the average cumulus cloud weighs about the same as a Boeing 747 jumbo jet. Imagine that. A floating mass in the sky with the heft of a fully loaded airplane. Now you might be wondering, if clouds are so heavy, why don't they fall on our heads? It's a fascinating question that leads us into the realm of physics and atmospheric science. It's a valid question, and the answer lies in the physics of air and water. The atmosphere is a complex system, and clouds are a perfect example of how delicate and intricate this balance can be. First, the water droplets in clouds are incredibly small, often less than 20 micrometers in diameter. That's thinner than a human hair. These tiny droplets are so light that they can stay suspended in the air. These tiny droplets are spread out over a vast area so their weight is distributed. This distribution is key to understanding why clouds don't simply plummet to the ground. Second, clouds are constantly forming and dissipating. They are dynamic, ever-changing structures that are in a state of flux. Warm, moist air rises and cools, causing the water vapor to condense into tiny droplets, forming a cloud. This process is continuous, with new droplets forming as old ones evaporate. As long as the warm air continues to rise, it supports the cloud and prevents it from falling. This rising air acts like an invisible hand, holding the cloud aloft. So, the next time you gaze up at the clouds, remember that you're not just looking at fluffy white shapes, you're looking at millions of pounds of water suspended in the air, a delicate balance of physics and wonder. It's a reminder of the incredible complexity and beauty of our natural world, hidden in plain sight above us. Keep exploring the cosmos. Thanks for watching. If you enjoyed these fascinating science facts, don't forget to like, comment, and subscribe for more amazing content. We've only just scratched the surface of the universe's mysteries, and there's so much more to explore. From the tiniest subatomic particles to the largest structures in the cosmos, science is a never-ending journey of discovery. So keep asking questions, keep your mind open to the wonders of the universe, and we'll see you next time for another adventure into the cosmos of curiosity.